Yeah, is this Valerie? How you doing? Yeah, I got it up and we'll take a look at it. Now and I'll show you where the official explanation is. Um, but under the Unit 2, you'll see the written assignment for the Unit 1 solutions here. And so I refer to the previous one. Now that doesn't necessarily always give you the explanation you need though. Now on this, if you had come up with f of x is equal to the square root of negative x plus 5 plus 3 over x, and domain has to be from 0 to 5, not including 0, and range has to be between 0 and infinity. If I look at just a portion of this, if I look at this right here, if I were to try plugging in values, for example, we said it's from 0 to 5, so if I were to try x is equal to negative 1, well, if I plug in negative 1, actually I could plug it in entire piece, we would have negative 1 plus 5 plus 3 over negative 1. A negative gives you a positive, and 3 divided by negative 1 is negative 3. And that would give us square root of 6 minus 3, which is okay. Now, problem with that is we said that our domain can only be in this range. We just found that x equals negative 1 works, which means your function's wrong. Now, oh, I'm sorry, go ahead. Mm-hmm. Right. Yeah, if you see, if I was building this, you're right on target on what would give you something that limits it, and that would be a square root. I could try different combinations. You tried negative x plus 5, which is 5 minus x. I might then try x minus 5. Now, what tells us the 5 to try is because of the endpoint. So the endpoint's 5, so we should try 5. So this would be a good first attempt. Then we try this. If I were to put negative 1 in, for example, that's outside of this. Negative 1 minus 5 is negative. We can't have a negative inside of a square root, so that wouldn't work. If I tried a value over here, which would be 6, then we get 6 minus 5, which is 1. And see, that would work. Right. And then now they got 5 minus x, but that's because there's another piece to it. So we basically tried every one of the pieces here, and none of them seemed to work, did it? But then, if you think going back to your example, so we start over. We start with that this right here. Domain-wise, this would give us, when you're finding the domain of what's inside of a square root, you take what's inside the square root and you set it greater than or equal to 0. And then I'll take the negative x, move it over the right side. And that gives us x is less than or equal to 5. So x is less than or equal to 5, which would mean -2, -1, 0, 1, 2, 3, 4, 5. Thinking of it in terms of integers. And then it's going forever this way. So we're right on target for part of it. We want from 0 to 5, don't we? So this is what we want to keep, thinking of just integers, though there's a lot more than integers involved. So then this part is what we want to exclude. And, assuming I could spell exclude. So we don't want negative numbers, basically. Well, if we just had a square root of x, then that would tell us that we can't have any negative numbers. Because if I put -1 in here, or -2 in here, it'd give me an imaginary number. So that tells us we want some kind of combination of these two right here. And that would almost give this to us, but it can't be 0, can it? So what would tell us maybe that it can't be 0 is if we actually put it in fraction form, like this. And then if I were to put 0 in for x, I'd have square root of 0, which is 0, and you'd have division by 0. So that's kind of the build-up from there. Of course, then the second part then would be, well, what's that do to my range? You know, have I messed up my range at all? Well, our range is supposed to be from 0 to infinity, including 0. So let's try our endpoints. Let's see, if I put 5 in, for example. That's our very ending number for our domain. I'd have 5 minus 5, which is 0, square root of 0 is 0. And this would be square root of 5, so I'd have 0 over square root of 5, which would give me 0. Well, that's promising. Then if you plugged in, for example, x equals 4. 5 minus 4 is 1, square root of 1 is 1. And this would be square root of 4, which is 2. And I see it's just increased. Now, the range, I could sit there and plug in a lot of values and eventually see the pattern. If you would have a graphing calculator, then you could plug it in there and see what the graph looks like. Do you have a TA3, TA4? If you and it's not a bad one, although you can't take it with you like when you go take a proctored test. But if you go to Google and you search for Peanut software, you might have to put graphing calculator in there also. Then it's a free graphing package. If I can find Peanut, there's Peanut. It's called WinPlot. And if I do window and choose 2 dimensions, and then choose equation and choose explicit, then if I did the square root of 5 minus x over the square root of x, assuming my low and high x values are fine, and click OK, then we can see the graph goes up forever. So that tells us it goes to positive infinity. It's always kind of tricky when you're trying to build a function based upon conditions. I find it challenging myself. I have to sit there for a while and before I can get it. Is that helping that one? Okay. During the what? I didn't hear your question. Not that one I showed you. Oh, if you under your first page here, if you click syllabus, then it'll tell you. I'll search because I don't know where it's at. Let me see if I can. There's somewhere else where it talks about it. Here it is. Yeah, you're allowed to use a basic calculator for the final exam. You're not allowed to use calculators on a cell phone, iPad, or similar devices, and that would include that Peanut software I just showed you. You couldn't use it. And then it says you cannot use any graphing calculator models with these features. Typewriter-like keyboard. That's the TI-92 Plus, Voyage 200, and so forth. But based upon this, you can use like a TA3, TI-84. Right. Oh. Now, did you get these right? I didn't even look at your answers, though. No? Okay. Let me see. Minus t plus h minus f of t. Yeah, this negative is wrong here. No, let me go over and show you, and then we'll flip back and you can see the difference. Okay. Now we want to find f of t plus h minus f of t over h. So first thing we want to do is we want to identify f of t. And that's right here, it's given. Then our second step is we want to find f of t plus h. Now evaluating is always the same. You go through and you replace your parentheses or replace your variables with parentheses. Now whatever's inside the parentheses right here is automatically what you put here and here. So put in t plus h here and t plus h here. Now you'd put it all in one line, but you started out correctly there. The minus is messed up here, and I'll show why here in a second. You should always simplify these over on the side, though, before you plug them in, because it's such a hard problem anyway, that if you do it over on the side, it'll simplify it. Now here I can go ahead and multiply the 2 through using the distributive property. 2 times t is 2t. 2 times h is 2h. Minus, and then t plus h squared is t plus h times t plus h. Then I got 2t plus 2h minus, and we want to FOIL these, multiply them together. We got t times t, which is t squared, t times h, which is ht, h times t, which is ht, and h times h, which is h squared, which gives us 2t plus 2h minus, and I'm keeping the parentheses around this because this minus has to change the sign of everything that follows it. And then I got t squared plus 2ht plus h squared. Now, there's no more like terms combined together inside here, so I'm going to take this negative and I'm going to carry it through. Now, when I do that, it's going to change the sign of all the terms inside. So we got 2t plus 2h minus t squared minus 2ht minus h squared. Now over here, yeah, right. So then, after we find that, this is a second mistake you made. When you plug it back into this formula right here, we're going to put the this right here in for f of t plus h. So we've got 2t plus 2h minus t squared minus 2ht minus h squared. And then you do a minus, and then I'll put a parentheses, because this minus that's right here has to flip the sign of everything that follows it. And our f of t is 2t minus t squared. So then that becomes 2t plus 2h minus t squared minus 2ht minus h squared. And again, a negative in front of your parentheses flips the sign of everything inside. So the 2t becomes a negative 2t. The negative t squared becomes a positive t squared. All over h. Now notice here, you had a minus 2t minus t squared. Minus 2t, but you didn't have the sign here. And then you combine together like terms. Here's a 2t and a negative 2t. Here's a negative t squared and a negative or a positive t squared. So then we got 2h minus 2ht minus h squared all over h. Now our main goal on the simplification on these is we want to eliminate the h in the denominator. And how we can do that with this problem is you notice how all the terms up on top have h's. So we can factor an h out. And that gives us 2 minus 2t minus h over h. And then this h cancels with this h. And our answer is 2 minus 2t minus h. Yeah, the negative is the main area we went wrong on that problem. Mm-hmm. Right. Oh, okay. Now you were asking about the self-quiz too, and this is the one you missed. Oh, okay. You're a good guesser. Well, let's take a look at this one first, and we'll go back and you can tell me what other ones you want to see. Okay, a frog jumps and takes 2 seconds to land. The path of the frog's flight is best modeled by a graph of f of x is equal to negative x squared plus 2x. And it says, what is the maximum height of the jump? It doesn't tell you specifically here, but whenever you have an x squared, you're going to have a graph looks like that, or you'll have a graph looks like this. When you have a negative in front of your x squared, then it's specifically going to look like this. Now, if I were to graph this on an x and y axis, and our frog is jumping like this, then the maximum height right here would correspond to our y values. Now, even more than that, your highest point or lowest point, depending upon whether it opens up or opens down, your highest point or your lowest point is also called your vertex. Okay, so now keep in mind, y is going to refer to our height. Now our x values. The other thing is talking about a seconds. So this is going to be our seconds. Some problems will give you that directly. This one we had to actually think about how does everything match up. But let's go through and find our vertex. Now we got 3 steps for finding a vertex. Our first step is to identify A and B. Now A is going to be whatever's in front of our x squared. And there's a -1 in front of our x squared. Remember, if there's no number, there's an invisible 1. Our B is going to be whatever number's in front of our x, which is 2. Now step 2. Plug in A and B into -b over 2a and simplify. Well, b we said was 2, so we're going to have -2 over 2 times a, and a was -1. That gives us -2 over -2, which gives us a +1. Then step 3. Plug the value from step 2 into the original function. And simplify. So we're going to take this 1, plug it in for the x in our original function. So we got f of 1 is equal to -1 squared plus 2 times 1, which gives us -1 plus 1, or wait a minute, -1 plus 2, which then gives us a +1. The exponent only affects what is to its immediate left. Unless there is parentheses, then it affects everything inside of parentheses. Hold on. Okay. So we got 2 examples we're going to take a look at. The oh yeah, do you want to see these? Okay. Well, this one right here, the exponent only affects what's to its immediate left, so only affects the 1. So the negative just carries down, and then this 1 squared becomes 1 times 1, which then gives you negative 1. But on the other hand, this one, since there's parentheses here, it affects everything inside the parentheses. So this one is negative 1 times negative 1, which gives you a positive 1. No, that's not too far. The class before this one, actually. Now, let me double check my math here. Okay, negative 1 plus, okay, 1. So our vertex is 1, 1. Now remember what we said x was. X is our seconds. So this is not only just referring to our x value, but that's our seconds. And our y value, we said, was our height. So when it's asking us what is the maximum height of the jump, it'd be b, 1. Mm-hmm. Right, that's this right here, f of negative b over 2a. This is where you take the value from step 2 and you plug it back in the original function. Now what other ones did you want to see? Right. Okay. That it should give you the answer. Yeah, like if I find b here, if I plug in negative 1 for the x, you got negative 3 times negative 1 is a positive 3 plus 1 is 4, so it should give you the y value. If I plug in negative 2, negative 3 times negative 2 is 6 plus 1 should give us this y value. Mm-hmm. Oh, okay. You want to see that one? Takes a minute for this to clear off. Okay. So we got f of x is equal to x squared minus 6. Now it says to find the x-intercepts. And to find the x-intercepts, you plug 0 in for the other variable, so plug 0 in for y, and we want to solve. Now in this one, we can take the -6 and move it to the left side, and we end up with x squared is equal to 6. Now this is something called the square root property. Square root property says if you have something squared equal to something else, then you drop your squared and you put a plus or minus square root around the other side. So again, you drop your squared, put a plus or minus square root around the other side. So in this problem, I dropped the squared and I put a plus or minus square root around the other side. And that's where they get the plus or minus square root of 6. Correct. Exactly. Okay. Okay. When you're talking about that, if it's visual, then you look at your graph, and this point right here, you notice how this is a low point relative to what's around it. This would be a local min. And if you had an x and y axis on there, you'd just go over to your y-axis and to your x-axis to see what the point is. Um, I don't know, to be honest. Oh, the A and B is just when they're those are just letters, meaning they can be any numbers. Just X and Y. Like the example I have over here, like if this was 7 and this was 3, then my local min here would be 3, 7. And they indicate this is A, and they indicate this is B. The what? Right. Yeah, this right here would be a local max because it's a high point relative to what's immediately around it. Um, this I don't know. There's different ways you could think of it, and it's interesting. The students have different interpretations of this. Lines can be used to approximate a wide variety of functions. Often a function can be described in many lines. And then if a stock price goes from $10 to $12 from January 1st to January 31st, and from 12 to 9 from February 1st to February 28th, is a price change from $10 to $9 straight line. And how can I use two pieces of lines to describe the price movements? Now, this is going from 10 to 2, so you can find its slope, couldn't you? And this is going from 12 to 9, so you can find its slope. And I'll give you the hint, for it to be a straight line, the slope of one would have to be equal to the slope of the other. But see, a lot of people have different interpretations of that. One person indicated, well, stocks never, they have a lot of fluctuation in them, even though it says from $10 to $12 during the month of January. It's never a straight line. It's kind of all over the place. So, yeah, so it's kind of up to you. A lot of these problems are kind of left kind of vague. They're not an exact answer to it. It's just they're more trying to get you to think about the possibilities. Right. Yeah, because it says up above the lines can be used to approximate it, but it doesn't say that. Here it's asking if it is a line, and well, I don't know about that. No. Right. Mm-hmm. Yeah, I think what they're really wanting in the problem is they just want you to look at the slope of the January and compare it to the slope of February and see if they're the same. But a lot of people have answered that in many different ways. Okay. Well, have a good night.